Hello guys, if you want to start detailing steel in advanced steel, this tutorial is for you. In few videos I will show you how to make a complete project from start to finish. I will show you entire procedure from setting up a new project to making a final set of drawings and also how to make revisions to your project. We will be making all of this based on maintenance steel platform for Chicago Transit Authority. In this video I will show you how to make bolted connection. This is not a standard advanced steel project, but because of that I have decided to share it with you. Once you get the idea how to detail this platform, making any other project will appear super easy. Stick around and check out other videos in this playlist. Consider subscribing, don't forget to click the bell icon to be notified instantly whenever I upload a new video. The project file is available on my website for free, link in the description below. If you need to buy advanced steel software, check out my link below to get a nice discount.
Open the project file. You can download this project file for free on my website. Link to this tutorial and the project file you can find in the description below the video. We are going to make a custom bolted connection for the double clip angle as shown in this drawing. Please note that I've highlighted in yellow all the important dimensions. On the 6-inch side of an angle, we are going to place two vertically placed bolts, 1 inch and a quarter from the edge, with spacing 1 3/8 of an inch between the bolts. On the 8-inch side, we are going to place two bolts 2 1/2 of an inch from the top of the W6 by 20 beam and 3 inches from the edge and 2 1/4 of an inch spacing between the bolts. There is no option in advanced steel to place bolts in the standard clip angle connection, so this is a workaround to this problem. I'm zooming in on the clip angle connection I want to modify. Now I am selecting an object which will be a part of the connection. Then I change the visual style to the 3D wireframe. Then open an advanced steel tool palette. We need to set a UCS on the face of the angle. The angle will be our X and Y axis and the bolt will be placed on the Z axis. Click on the top middle icon with the number 3. Now place the first point of the axis in the corner of an angle. The second and third point snap to the outside and inside corners of this angle. Very important is that you need to pay attention to snap exactly in the corner points, otherwise the work plane will be skewed. Now is time to draw some temporary lines to define where you want to place the bolts. I am drawing 1 1/4 of an inch line from the bottom edge of the angle. Since the other angle is on a different work plane, I cannot snap my line to this angle. The workaround is to trim to this line. I finish my line a little past this line. Now I need to copy this line 1 3/8 of an inch from my first line. I am deleting the first line since I'm not going to need it. Use TR trim command to trim the ends of our temporary lines. Select those lines, click G for the group and click enter. Set UCS to global, and let's take a look at how it looks in 3D view. Our lines are aligned correctly on the work plane we set earlier. Go to the Objects tab and go to Switch Bolt Type and choose Bolts. Select Rectangular, 2 points. Be sure to set the work plane to be on the face of the angle, otherwise, the advance will place the bolts facing the wrong direction. Now the work plane is set. Let's try one more time. Click Rectangular, 2 points. Select all 3 elements to connect. Click Enter. Define the rectangular on the temporary lines we drew previously. Dialog box will open. Now check if all the parameters of the bolts are as you wish they should be. Structural engineer specified 7/8 inch bolts for this connection. Now the distance, enter the bolt quantity in the vertical and horizontal planes. I have bolts in axis X set to 1 and in the axis Y set to 2. Also, the spacing between the bolts is 1 5/8 of an inch. Everything looks fine. Close the dialog box. When you go to front view of our connection, which in our case is top view since we modified UCS, you will notice that the bolts specified by structural engineer are too large. Let's make those bolts a bit smaller so you can actually tighten them. Double click on the bolts and change the size to be 3/4 of an inch. Close the dialog box. Change the viewport type to be conceptual. Now when you click on the 3D view, you can clearly see that our connection is just perfect. All the holes are drilled. Right-click on your mouse. Choose the End Object Isolation option. Now let's take care of the other side of an angle with horizontally positioned bolts. Choose both angles and beam. Choose the Isolate Object option. Place UCS at the corner of this angle to set up a face of this angle as our work plane. Change a view type to 3D wireframe. As you can see, we have to place our bolts 2.5 of an inch from the top of the beam. Since the beam is on a different work plane than our angles, we have to do trim temporary line again. Draw the line going up. Type TR for trim command. Click on the part of the line you want to remove. Press L to draw a line. Now, draw the line with the beginning insertion point of the temporary line we just drew. Type 2.5 and click enter. Now go to the left and type 3 since our bolt pattern should be 3 inches from the edge. Then go 1 inch down and 2 1/4 to the left to specify a temporary line for our second bolt in this pattern. Delete all the temporary lines we are not going to use. Now in between two angles draw a line. We need to make a temporary line to mirror our pattern onto the second angle. Now draw the line starting in the center of the short line. Delete the short line, we're not going to need it. Select the group with the lines. Type MI for the mirror. Mirror the group on the center line we just drew. Delete the mirror line. Select both groups and group them. We can use this group to create a bolted connection on other clip angled connections we have in our project. As you can see in 3D view, our lines are drawn on the wrong face of the angle. Let's correct this issue. Change the view type to wireframe again. Let's check on which plane those lines are drawn by drawing a line and trim it. It is drawn on the back face of the angle. Draw a 1-inch line since we need to draw a rectangular pattern for our bolts. Select all temporary lines and hit G for group. Move the groups to the front using an angle thickness as a guide. Now when you change the viewport style to conceptual, you can clearly see that our lines are drawn on the face of the angles. Change a style to 3D wireframe again. Choose the bolt rectangular option on the ribbon. Choose an angle and the beam. Click Enter. Now draw a rectangle to place our bolts on the temporary lines we drew. Check the bolt type and invert them. They should be facing the other direction. I like to keep things organized. Close the dialog box. Repeat the procedure on the other side. Choose the beam and the other angle. Draw a rectangular for the bolt pattern. Double check the bolt parameters. Close the dialog box. Change the view type to conceptual. Right-click and choose an option, End Object Isolation. Our clip angle connection looks very good. Now you can copy all the temporary lines we drew for our connection onto other clip angle connections and make those bolted connections for other members. Do not just copy bolts. I know theoretically, it makes sense, but disaster will happen. You will copy not only the bolts but also the beams to which all the bolts are connected. I know it makes no sense at all, but this is how Advance will perform your request. You will have a countless amount of beams, and to clean up this mess later, very difficult. Let me know in the comments section if you like this method of making this type of connection, or maybe you have a different way to go about this. Thank you, see you next time.